So then after getting it b equal to r sine angle, from sine angle equal to opposite over hypotenuse. What about cosine? Cosine angle is adjacent divided by hypotenuse. So what is adjacent here? It is a. So cosine angle equal to a over hypotenuse, which is r. So make a as subject of the formula. Our a is r cos sine angle. So that is our a. Then from algebraic form, which is z equal to a plus bi. So what is z now? So our z is a. Our value of a is r cos angle plus our value of b is r sine angle. That is I, r sine angle. So r is common. We take r out of the bracket. So this is cos angle plus I sine angle. So this is z in polar form. That's what we call z in a polar form. So this is the polar form or trigonometric form. Trigonometric form of complex number. Of complex numbers. So that's how we write z equal to r into bracket cos angle plus I sine a angle. So let us see examples. Let us see examples. Example number 1, express the following complex numbers. The following complex numbers into into polar form. We're going to express it into polar form. Into polar form. We have A. Our A is saying Z equal to 1 plus I. And B equal to Z equal to 1 minus I. So before we do this example, how can we find, we have seen that tan angle equal to adjacent opposite over adjacent, which is B over A. That's our tan angle. But how do you know that? So we have a circle, which is a trigonometric circle, and it has quadrants. There is first quadrant, second quadrant, third quadrant, and fourth quadrant. So when you are in the first quadrant, our angle equal to alpha. That's where your A is positive, even B is positive. But when you are in the second quadrant, our angle equal to pi minus alpha. When A, it will be negative. Even B, B is, it will be what? Positive. When you're in the third quadrant, our angle will be, because we are here in third quadrant, we have already crossed 180. It will be pi plus alpha. So there, A will be negative, even B is negative. Then what about when we are in the first quadrant? When we are in the first quadrant, our angle will be equal to negative alpha. So A will be positive, but B is negative. So this one will help us to get the real value of angle. So we're going to do this example. Then it will help us to know where we classify the angle. So now, let us do examples here. So number A, the question is saying express the following complex numbers into polar form. We have A, Z equal to 1 plus I. So here our A equal to 1, B equal to 1, coefficient of I. And you see all of them are positive. So remember, polar form is Z equal to R into bracket cos angle plus I sin angle. This is the polar form. We're going to express this one into this form. So what is R? R is the modulus of Z. How do we find the modulus? This is square root of A squared plus B squared, which is root 1 squared plus 1 squared, because our A equal to 1 and B equal to 1. So this is root 2. That implies that our R is what? Root 2. So what are we meaning? We're meaning to find the angle. So before you get angle, we're going to find tan alpha. Tan alpha equal to B over A. So how do you find tan alpha? Tan alpha, which is equal to B over A, that is 1 over 1. So then alpha is tan inverse of 1, because 1 over 1 is 1. So tan inverse of 1 is pi over 4, which is 45. So after getting tan alpha, which is pi over 4, remember, since our A is positive and B equal to positive, it is in the first quadrant. In the first quadrant, angle is what? Is the same as alpha. So our angle equal to pi over what? Equal to pi over 4. So this angle is the same as argument of Z. The argument of Z is pi over 4. So after getting pi over the argument of Z equal to pi over 4, what will be our Z in the polar form? Which is equal to R into bracket cos angle plus I sin angle. So now our R is root 2. To be root 2 into bracket, this is square root, into bracket cos pi over 4 plus I sin pi over 4. So that's how we write Z into polar form. Then the B, Z equal to 1 minus I. You see now, our A is positive, but B is negative. So, which quadrant is that? My A is positive, which is here, but B is negative. So this is the first quadrant. It is in the first what? Quadrant. If it is in the first quadrant, it means that our angle will be equal to negative alpha. Our angle will be equal to negative alpha. So then tan alpha, I don't consider their signs when I'm finding alpha. So I will take A as 1, and I will take B as negative 1, as positive 1. I just ignore this negative when I'm finding what? Tan alpha. So which is B over A. So tan alpha is equal to 1 over 1. So alpha is tan inverse of 1. Alpha equal to pi over 4. So alpha is pi over 4, but our angle is not pi over 4. It will be negative pi over 4. So our angle is negative pi over 4. So then R, what will be our R? Our R is the modulus of Z, which is the square root of 1 squared plus negative 1 squared. So then this is root 2. Our r is root 2. So after that, z equal to r into bracket cos angle plus I sine angle. So now z equal to root 2 into bracket cos of negative pi over 4 plus I sine of negative pi over 4. So now z will be equal to root 2 into bracket. You know that from when you have cos of negative angle, it's the same as cos of that angle. But when you have sine of negative angle, is minus sine of that angle. So from this one, then cos of negative angle is cos of that angle, which is cos pi over 4. Then sine of negative angle is negative sine that angle, which is minus I sine pi over 4. So that is answer for part B. So that's how we express algebraic form into polar form. So let us see as examples. So see z equal to negative 1 plus I. How can we express that one into polar form? You see our A is negative, but B is positive. When we draw our circle here, A is negative. The negative side is here. But B is positive. So they meet in the second quadrant. They meet in what? Second quadrant. If they meet in second quadrant, our angle is equal to pi minus alpha. Why is it pi minus alpha? Because in the second quadrant, when you consider this is 180. This is 180. It is like this. You know that this is 180. This is 180 degrees, which is pi. So if that is 180, which is pi, it is not yet reaching here. That's why we take 180 minus that angle. So it will be pi minus alpha. How do you get tan alpha? Tan alpha equal to B over A, which is opposite over adjacent. So our A, we just consider positive sign only. We don't consider the negative. So our A is positive, our B also is positive 1, coefficient of I. I ignore this negative when I'm finding what? That alpha. So then now, tan alpha equal to B, 1 over 1. So alpha is tan inverse of 1. Alpha is pi over 4. So then, what will be our angle? Pi minus what? Alpha. So that is pi minus pi over 4. LCM is 4. 4 pi minus pi. So therefore, our angle is 4 pi minus pi. That's 3 pi over what? Over 4. This is our argument. Our argument of Z is 3 pi over 4.